Algebra I Honors, Lesson 4.5, Graphing Linear Equations, and 4.6, Functions. So, been building up to this. Would love to look at graphs in algebra. Absolutely love it. I just showed you in the last lesson that certain equations are linear, and when you graph it, it forms a line. If you look at data, though, linear means it goes up by a set amount each time. On a graph, we call that slope. So I'll show you that when we actually graph something. So standard form of a linear equation, and this is standard, it's very specific, is ax plus by equals c. I hate it, not going to lie to you. If we have 3x plus negative 4y equals 1, people say, oh, that's great because we can graph it by intercepts, because we can say when x equals 0, let me make this 12, just for the fun of it. When x equals 0, y equals negative 3. Hey, there's a point. 0, negative 3 down here somewhere. When y equals 0, x equals 4. So hey, here's another point, and we can graph it. Well, yeah, if all your point is just to graph it, then great, you're good to go. We want to do more than that. Graphing's important. The most important thing, I think. But there's other stuff going on. So I'm not a big fan of it, but, be aware, it's just called standard form. It's not magical or anything like that. Notice that this is to the first power, even though it's an invisible 1. Notice that this is to the first power. Notice there is no x or y on the bottom of a fraction. All right. These are things you have to be aware of. A, B, and C, by the way, in this equation are always constants. So we just call them A, B, C as a generalized thing. But notice all down here, immediately they all get numbers. So determine if each equation is linear. Yeah, linear. And write it in standard form. Sure, whatever. 2x plus y equals 5. Not linear. Why not? Because we're multiplying an x and y. Hey, I didn't tell you that. Yeah, get over it. Some of these are best learned by examples. Can't multiply an x and y. Well, how come? Because if you solve for y, you'd have an x on the bottom. I did tell you that. Here, it's in standard form, but we can divide a 3 out of everything. So we want to have it down as much as possible. In reduced form, I believe, would be a better way to call it. This one, we also don't want any fractions, so I'm going to multiply everything by 3. We'll get y equals negative 3. And that's a linear equation. You say, well, there's no x. It can't be. Yeah, I never said you couldn't have an x. Just said it couldn't be on the bottom, and it had to be to the first power. And couldn't be more than the first power, I should say. So those are all linear. We can graph by making a table. We've done this. So we don't need a zillion points. Let's just go with, like I said, 0's handy, negative 1 and 1, and I'll be a good sport and give you 2 also. We can get y alone, or we can just plug it in and solve it. So for 0, we get 0 plus 2y equals 6. Y equals 3. 0, 3. I'm going to do 1 next. For 1, we get 1 plus 2y equals 6. And this is not meant to be neat. No, I'm erasing to make it neater. It's just quick and dirty. Let's figure out what's going on here. Y equals 2.5. 1, 2.5. Let's try negative 1 up here. Negative 1 plus 2y equals 6. Shorthand, 2y equals 7, y equals 3.5. And last but not least, 2, which I'm going to do in my head. 2y equals 4, y equals 2. And lo and behold, now we get to draw a line because I didn't say, here's your domain, don't mess with it. I just said, here's a table, do whatever you want. So we use these 4 points to create the line. One of the great skills in high school is learning to draw a straight line, so good luck with that. So that's how we used a table, like I said, very middle school concept to create a line. Better would be a faster way because that took some time and that would get extremely upsetting. Since it's linear, we only need 2 points to determine a line. Like we talked about before, we could use intercepts. How do we find intercepts? Well, we say when x equals 0, y equals something, and when y equals 0, x equals something. That's it. And just go baby go. There's nothing else to say. So you could do this with intercepts. Again, I'm not a huge fan, but sure, why not? If x equals 0, negative y equals 4, aka y equals negative 4. Our ordered pair is 0, negative 4. If y equals 0, we get 4x equals 4, x equals 1. There we go. 2 points, and we're off to the races. Again, I'm not a big fan. Yay, we graphed it. So let's give you a word problem. Taxi charge is $2.25 plus 75 cents per mile. This is what I meant by it goes up a set amount each mile, 75% every mile traveled. So here's our equation. In the near future, you'll have to do that. Let's graph it. So when c equals 0, try that again. When m equals 0, c equals 2.25. So this is c, kind of like a y, equals blah, 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 kind of like an m. So our ordered pair is 0 on the m, 2.25. When c equals 0, m equals, tricky, 0 equals 0.75 m plus 2.25 minus 2.25 minus 2.25, negative 2.25 equals 0.75 m. Divide by 0.75 on both sides. And calculator time, 2.25 divided by 0.75, we get 3. M equals 3. So 1, 2, 3, c equals 0, m equals 3. This seems very, very wrong to me because I did not see my negative. When m equals negative 3, 1, 2, 3, c equals 0. Now, time can't go negative for a taxi. So everything to the left of the 0 is kind of pointless, but it's not a bad thing to see it. So really the graph starts here, it goes up. So you travel 18 miles, how much will the fare cost? Well, we don't quite have enough room to show 18 miles. At 10, it looks like it's about $11, something like that. So if I had a guess for 18, I guess I could go to 9, say it's about $9, probably about $18, $19. So cost equals 0.75 times 18 plus 2.25. I wasn't too far off. Cost is $15.75. Notice the limitations of the graph. We need to show it all, and it's not as precise, but it gives us some good data to work off of. Now this leads us from a linear relation to functions. Incredibly complicated stuff, a function, and math teachers make a great mistake of showing it as something very simple and not all that complex. It means that you have a good model. I decide to create a computer program which tells me, here's the day of the year, here's what the temperature should be outside. So on the 100th day of the year, which gets you January, February, March, just into April, it should be about 52 degrees Fahrenheit outside. That means you have one input and exactly one output. Now we could have a repeat at the 310th day of the year. We could also have 52 degrees, but we only get one output for 310. The problem is if when I say, hey, it's 100th day of the year, it's 52 degrees, or maybe it's 30 degrees. That is not a function. An extremely complex idea and an extraordinarily important one. If data is not a function, I say, hey, when should I buy my set of stocks that I'm focusing on? It says right now, or maybe in 2 weeks. That's not a function. That doesn't help us. It's a bad model. So I like to say a function is a good model. If you remember that, I think it'll help you out a lot. There's lots of other ways to do it. So how do we know if it's a function? Any y repeats for 1x. And by the way, y equals something x, a linear relation is always a function. Kind of nice. So we have -4 maps to 9, -1 to -6, 1 to -6, 3 to 11. This is a function. -3, 2, 3, 2, 2 maps to 5, or 2 maps to 4. So that's the problem when we have that going on. This is not a function. (2x minus y), 1x equals 0, y equals -6. When y equals 0, x equals 3. The other way to tell a function is you drop all these vertical lines. It is called the vertical line test. Vertical line test. Function. Vertical line test means if I only hit once, it's a function. If I hit it twice, it's not a function. I had to write that down. It's pretty important. Here, look for repeats. -2, 1, 3, 5, 7. No repeats. That's a function. Repeats in the x. I've mentioned this before. What are discrete and continuous functions? This is just points. For example, days are discrete. There's only, there's not 1.1 days if I'm measuring what happens on any given days. It's today. I have a dentist appointment today, not on day 1.2, on the day. Continuous, just what it sounds like. It's a line. Could be also a curve. Goes on and on forever and ever. So now we say which ones are discrete, which ones are continuous. The amount of rain during the duration of a storm. Now, if you want to get nitpicky, you can say, well, each drop is, if we're measuring in drops, that would be a discrete amount. But if we're measuring it with the way it's typically measured with a cylinder sitting outside and just measure how much it's rain, this would be continuous because the rain is small enough to consider it continuous. The cost of rentals based on the number of DVD rentals. The cost of the rentals based on the number of DVDs you rent. That's discrete. You can't rent half a DVD. Now, if we were measuring for America, it'd almost be continuous, but now it'd still be discrete because there's billions being rented. You could almost say, yeah, they all kind of work together. Total money you have based on the number of dimes you have. That's going to be discrete. hits certain points. 10 cents, 20 cents, can't have 21 cents, can't have 20.02 cents, so on and so on. Easy to argue that in the grand scheme of things, everything's discrete. One molecule, two molecule, one atom, two atoms, but generally speaking, no. So function notation drives people crazy, and it's really not that hard. Rather than write y equals 3x minus 8, we write f of x equals 3x minus 8, meaning that it's a function of x. I think I just lost my pen. Nope, it's back. So if it really drives you crazy, just write y equals. In a function, x represents a domain and f of x represents the change. Well, no kidding, it's y, and we already talked about that. How do we translate a function? Well, we just, instead of f of x equals 3x minus 8, we just write it as y equals 3x minus 8. Problem is, we're going to have this f of 2, and people are like, I don't know what to do. It's not really a big deal. It just means y equals 3 times 2. Because that's f of x. F of 2 means plug in 2, see what happens. That's it. That's it. It's really simple. On the ACT, not that big a deal. Just different, which people can't handle. So f of negative 2 means 2 times negative 2 plus 5, which is 1. F of 1 means 2 times 1 plus 5. Well, what about the 4? Who cares? I just did f of 1. F of 1. Okay, and now plus 4. 2 plus 5 is 7 plus 4 is 11. Not a big deal. F of x plus 3. 2 times, and I do it this way. Here's my function. I write it like that. What's going in? Well, whatever's in here. X plus 3. That is challenging to understand, and that really freaks people out. Once you do it a few times, it's not that bad. More. If h of z is z squared plus 3z minus 4, what's h of negative 4? Always, when you put it in parentheses. 16 minus 12, 4 minus 4 is 0. H of 5a, 5a squared plus 3 times 5a minus 4. I feel like we've just kind of jumped things a little bit. 5a squared is 25a squared. That's challenging the first few times you see it, but get good at it. You square everything inside the parentheses. Done. Can't simplify it. Hey, you can factor that, or no, you can't. Yes, it doesn't matter. Nobody asked you to factor it. It's not said equal to anything. 2 times h of g. So what goes in for z? G does. So g squared plus 3g minus 4, all of that times 2. 2g squared plus 6g minus 8. And now we got 2 of them together. This gets a little dicey. So g of negative 1, well, that's easy. We've already done that. Don't forget your negative 1 squared plus 1. 1 plus 1, because the negative squares away, is 2. F of 3a squared, that's a little tricky. 4 times big parentheses minus 5. All right, just plug that in. Multiply the 4 and the 3 out front. 12a squared minus 5. F of x plus 5. 4 times big blank where the x plus 5 is going to go. Minus 5. Plug in the x plus 5. And the hard one, f of g of x. So f, like I said, 4, big blank, minus 5. G of x is x squared plus 1. Just plug it in right here where there's a variable. 4x squared plus 4 minus 5. 4x squared minus 1. That's it. That's a lot. It's a lot of math. So you got work to do. Get cranking. As always, good luck and happy mathing.